Go.
Hello!
Okay, that's it. Hello, Mr. Eric. Are you right? What's metric?
Is this
In
big?
mathematics, what's metric?
Well, it's this big list thing with
Can
numbers.
you draw? Can you draw? Just draw a 2 times 2 metric. Okay? 2 times 2 metric.
Okay.
Yeah?
That-
Okay. 2 times 2 metric.
1, 2, 3.
Well done, well done. So there,
Something.
you can use the square bracket or you can just use mathematically just 2 vertical bar line. Okay? This is the same thing. So this is 2 times 2 metric. What does it mean? 2 rows, 2 columns. Yeah? If this is A equals that. How can we represent it in Python, in computer? What kind of data structure can we use to store these kind of 2D metrics? The metric in,
One.
what's this in Python?
List.
List. And list is the one dimensional. So how can we store list using list in two dimensional? So can you write a Python code? A equals what? Can you write it to store list?
Huh?
Can you store list using the Python list? A equals what?
It's 1.
Look here, a list. So what's this? It's the same as a list of 2 lists, right?
1, 2. Then
Yeah. So look.
3, 4.
So a list 1, 2, and comma 3, 4. Right? This is how you store it in Python. So what does it mean? This is the list. Contains 2 sublists. The first list is the first row. The second list is the second row. Okay? Yeah? So how can I get the number of rows of A? How can we get the number of rows of A?
Length A.
Well done. And how can we get the columns, number of columns in A?
A0. Length A0.
Well done. Very well done. Okay? Very well done. Okay. Okay, so in mathematics, we can add 2 metrics, A plus B, or A minus B, if it's the same size. Same dimension, which means the both metrics have the same number of rows, same number of columns. Yeah? So if I have a metric like 1, 2, 3, 4, if I add another metric, 3, 4, 2, 1, can you imagine what can we get? Can you imagine how do you solve this problem?
We just add these two the same position, please.
Okay, so 1 plus 3 equals,
4.
and then what's next?
6.
Yeah, same position, yeah? And then same position, 5. Same position, 5. And how about like 1, 2, 3, 4 minus 3, 4, 2, 1. Okay? Can you imagine what happened here?
It's -2.
Minus 2.
-2. 1. 3.
Okay, okay.
Minus
So
2
yeah,
minus
that's
1.
addition and subtraction is very easy. We just perform these operations on the elements at both metrics, the same position. Okay, and then we put it in the same. Yeah, put it in a result. Yeah. Okay, so let's implement this. Okay. If they're some different size, we cannot add. Yeah, we prefer to throw an exception. Yeah, if the size are different, right? Okay. Define F A B.
Column.
Yeah, well done, good job. Okay, let's do this rows A. Rows A equals length A. Yeah, you know that, right?
Yeah.
And now we need to assert. What's assert mean?
To check.
To check, yeah, to tell computer that, okay, I'm assuming R is strictly bigger than 0, okay? Yeah? If you found out R is 0, what happened? The computer will scream. Okay? It was refused to continue. That's what it means, yeah? And C equals length, what? What? 0, yeah, this is the column. And now I need to check the rows and columns are the same as the size of B, yeah? So, assert R equals what? R equals what? What's the number of rows in B?
B.
What's the number of rows in B?
Not B.
Length B. And the columns needs to be same. This column length
B.
what?
0.
B0, B at 0, okay?
0.
Now Okay, so this is just to check, to prepare that, okay, we have the two metric which have the same size, A and B, and we want to add it together. So there's one way to do it is to allocate a metric of a separate metric, right? Yeah? And or we can just add it to A, right? Yeah, do you get it? So let's do this one by one, okay? How can we add it to A? For R in range row R, right? For C in range column. Then what should we do? The A, R, C. Can you imagine what's the operator here? And then corresponding one will be B, what? Yeah? I go through each rows, I go through each columns. RC, what's this? I want to add this to A. So what should I put? Plus,
Equal.
and what should I put here?
C.
RC, yeah, the same position, right? And then return A, yeah? You return A. You see? Very simple. Easy, yeah? You know it. What's the time complexity? What's the time complexity? What? There's no N here. What's R? Oh, what? What's R? What's what? What's the time complexity? Oh, RC, yeah. Wait, what's the space complexity? Are we using any space? We're changing the space, so we're not using any space, yeah? Oh, we are not using any space. Oh, one, come on. Okay, so
No.
if this is subtract, so if this subtract, there's only one character we need to change. If this is subtract, I want to subtract A to B from subtract B, A from I want to subtract B from A. So I change this to
Minus.
yeah, well done. Got it. Yeah. Same complexity ORC because we need to go through each element in the R in the matrix and we change that. Okay. So you get it, yeah? So now we talk about how to allocate one. Yeah. Sometimes you are not allowed to change the metric. Yeah, because you are changing the metric here. So if we can allocate the metric, how can we allocate metric? C equals the same size. Yeah? We add at the beginning. What? 0. We put it 0. 4 underscore in range. How many columns of how? This is how many columns? First of all, how many columns of this return metric? Columns C. Yeah. Yeah. And I will do this. Yeah. This is the each row has the C columns, and then 4 underscore in range. Range what? How many rows? How many rows? How many rows? Yeah. Okay, so if this is the way to allocate a list of lists with R columns, R rows, and C columns, and then once you allocate it, you just do this. Yeah, CRC equals. You can just do it equals ARC, and then minus BRC or plus ARC. Yeah, got it? And if you implement this, what's the time complexity? What? What's the space complexity? Yeah, we are allocating this space. Okay, got it? Yeah, it's not easy. It's not hard. Yeah. Okay. So this is the matrix add and plus and subtract. Add and subtract. Okay. Okay. So let's talk about multiply. Okay. What's multiply? A times B.
Let's technically say.
Yeah, sit down. Okay, so A times B, okay? So the matrix only has plus, subtract, and multiply. There's no division, okay?
Why?
There's no division. But you can approximate, we can define the division by using some the inverse of matrix, which we'll talk about later. So let's skip the division for now, okay? A times B. What's metric? Metric multiplication is different. It's different, okay? So, look, I show you, okay? 1, 2, 3, 4 times 1, 1, 0, 0 equals what? It's hard, yeah? So look.
I did it.
No. is
Or-
look, you take the rows for the first one, yeah, and you take the columns for the second one.
Mhm.
You do the dot product. Remember what's dot product? We talked about that the day yesterday. Yeah, dot product. Yeah, dot product. 1, 2, and then look 1, 2, and 1, 0. What's the dot product? Do you still remember? What's the dot product? These two plus these two. What's dot product?
Is
A and B dot product equals what? Sum of I equals 0 to n minus 1. AI times BI, right? Remember? Yeah? So 1 times 1 plus 2 times 0. Okay? What's this? 1.
oh,
1. Yeah?
I think it's 1 times 2. Oh yeah, it's
You take this and this, remember?
Oh yeah.
You add it, you times it, and you all add it together. This is added, okay? So look, right? Look at my hand. Yeah?
Mhm.
The dot product, and then you put this answer here, which is 1, right? Okay? And
How about
again,
the next one.
yeah, next one here. You take this and this. Dot product.
Why you're not taking number 1?
No, you just look at, you take this first row, second column, first row, second column, first row, second column. So you'll be 1, 2, dot product, and what? 0, 1. What's this? 1 times 0 plus 2 times 1 equals what?
It's
2.
2.
Okay, so the same. The second one, 3, 4, 1, 0.
3, 4, 1, 0.
I tell you it's 3, yeah. And 3, 4, 0, 1.
3, 4, 0,
3, 4, 0, 1. 3 times 0, 0. 4 times 1, 4. You see?
1.
Yeah?
That's exactly the same as this
Good
one.
job. Look at this. What's that mean? Remember, you have a metric. If it's a square metric, with the diagonal only fill 1, right? Yeah?
Yeah.
All others are 0. We call it identity metric. Okay? So this is identity metric. And this is also identity metric. Look. 1, 1, 1, 0, 0, 0, 0, 0, 0. Can you write the 4 times 4 identity metric? 4 times 4 identity metric.
Line.
Yeah.
1, 1, 1,
Wow.
1.
And all others 0. Okay.
0,
Okay.
0, 0, 0,
Yeah.
0.
Yeah. You see? Okay. Yeah. All 0. All 0. So identity metric, we use the I to normally represent as identity metric. Okay. Look, in order for the multiplication to happen, look, the number of the columns, yeah, needs the number of columns of A. The number of columns of A. Let's say CA needs to equals what? CA and needs to equals what?
Columns.
Row B, yeah? Yeah? The number of columns needs to equals to the number of columns of A needs to equal the number of columns of B, right?
Mhm.
Right? If it doesn't equal, there's no dot product, you cannot multiply, okay? Got it? And what's the result? Look, if this is 1, 2, 3, 4, 5, 6, right? You can times 1, 1, 0, 0, and that will return what? That will
1,
return.
2, 3, 4,
You will be the same, yeah, as I say, yeah, right? Look, the number you can do this, yeah. 1, 2, 1, 0, that's 1. 1, 2, 0, 1 is 2. 3, 4, 1, 0 is 3. 3, 4, 0, 1 is 4, yeah. 5, 6, 1, 0 is 5. 5, 6, 0, 1 is 6. So look, this is a metric of what? 3 rows times 2 columns, right? Look here. And this is identity metric of 2 times 2. This needs to be the same, right? This needs to be equal, right? Got it? Yeah?
but this be your answer.
Yeah. So what's the answer? What's the dimension of the answer?
This.
Yeah, I know, but what's the dimension of answer? Is 3 times 2, right? You see, because these two are the same. And the answer will be 3 rows, 2 columns. Got it? Yeah?
Mhm.
Does it make sense? Look, A times B. If A the metric is R is okay. Let's do this. A columns and B. A columns and B. A rows and B columns, and then B is B rows and C columns. So what's the dimension of the result C? Can you tell me? Come on. Okay, A metric is A rows, B columns. B metric is B rows, C columns. And
A times C.
yeah, we're done. A times C. That's what I'm talking about, yeah? Okay? Got it?
Mhm.
So any metric times the B identity metric is cell, right?
Yeah.
So can you tell me A times B, is it the same as B times A? Equal or not equal?
Not equal.
Not equal. But you can plus the number. 1 plus 2 equals 2 plus 1, right?
Mm.
Yeah? 1 times 2 equals 2 times 1. The numbers are okay, yeah? Exchange, yeah? But metric is not. A times B metric is not the same as B times A, okay? Yeah, because sometimes, look, if you 1 times 3, and then you want to times 3 times 5, you can times the result will be 1 times 5. But if you reverse it, what happened? What happened? 3 times 5 times 3 times 1, right? You can't multiply, right? Because this not the same side, right? Right? You cannot multiply, right? Got it?
How
Yeah.
about these two things?
Yeah, then it's okay. So the middle, got it? The number of, look, just remember my hand, yeah? Put it here. Put it here. Yeah? Got it?
How do you remember where you put it?
Good job. Look, if I, look, this is the first row, right?
Mm-hmm.
And I want to do this the second column, right? So where does it go? First row, second column. So here, first row, second column. Second row, first column. Look, second row, first column.
This one.
Yeah, second row, first row. You see? Got it? That's magic. So let's implement this, okay? And that will be it. Okay? That will be easy, yeah? It'll be easy. Divide, multiply A and B.
Gotcha.
Okay, so the first few are similar, right? So we first of all we need to get R equals length A, and then we need to assert R bigger than 0, and then look C equals length B, length A, right? We need to assert C is B bigger than 0, and we also need to assert what? Come on, this is different. We want to assert what? How, in what cases A can multiply B?
Oh.
The first one, look, A is R times C, and then the second, this B, the B is what? How many number of rows of B is length B, right?
Mm-hmm.
Column, length B 0. So which two numbers should be same? R times C times this. Which two numbers should be the same? Come on. Huh? The first A is R times C,
Yeah.
and B is this times this. In order for A times B, which two number needs to be the same?
At least one. Please.
What? 1, 2, 3, 4. This is A, and I want to times something. Remember, so this needs to be the same as this.
Mm-hmm.
This is number of columns.
Mm-hmm.
And what's this?
The number of
Length of the rows of B. So assert C equal length B, right? Yeah, this is just to prepare, okay? Now we have these, then we allocate, yeah, we allocate. Result, okay, let's do this bigger C. C equal, this is biggest, let's do it answer, okay?
Just do
No, M, for example. M equals
YM.
R is what? R is R, A, the size is R times C, okay? And then B is length B times the length B 0. Okay, so what's the result? What's the result metric M? What's the result metric M?
It is
Is what? What? What's the R times what?
C. No B. No B.
Length B 0, come on. These two are the same, remember? So R columns and length B R rows and then B columns. R rows and then we have to do this first, yeah. 0 for underscore in range length B0, right? We define this. And then 4 in range R, right? Okay? So let's just define this, and then we just need to go through each one, okay? So look, A is here, right? So we just go through it. For R in range R, right? And then we go to C, yeah? For C in range C, right? So we go through each one, and then we need to go through what? For K in range what? In range. So what's the result? No. Look, R, the result will be length B0, right? So we need to go to length B0, right? Because this is the final dimension is R times length B0. So we're going through the first two loops. We're going through each element in the result, right? So and then for K will be in range what? In range BC, yeah? Because C. Okay, the range C. Let's do this. IJ, okay? IJ in range C. Now all I have to do is to sum up each one. So M IJ, right? MIJ is this one, yeah? Look. Look. This one times this one equals this one, right? So look, I'm timing this. This is A, this is B, right? And I want to put it here, right? I want to sum up here. So each one will be the contribution, yeah, from A to B. Yeah? So plus equal what? IK is the C, yeah? IK, yeah? Look. AIK times BK. B, look, B is K, yeah? K what? What's here? What's here? AIK times BKJ, right? Okay, and that's it, return N. This is a bit tricky, yeah? It's okay, you don't understand in this moment, but take a look. So why this is MIK? Well, MIK here?
This MIJ.
MIJ will be what? Will be added, keep adding this bit, yeah? AIK times K will be 0 to C, yeah? 0 to C, right? Look at my hand, 0 to C, yeah? This is this column. And AIK here times BKJ, KJ, J is the, which column, right? Which column, right? Here, look, and then what's K? K moving, look, alright, look at me, moving. All this added to MIJ, here, here. MIJ is here. This is MIJ. Can you look at me? Not moving around and around. Look, this is MIJ. Here, this is the result M, right? And then look, A, this is B. AIK times PKJ. Add it from 0 to C, okay? Got it? What's the time complexity? This is a. Oh, what? What's time complexity? What's the time complexity? Look at how many
This 3 loops.
Sorry?
3 loops.
This is R. This is length B0. Let's call length B0. No. Length B0. Let's call it.
Let's call it length B0.
Let's call it, I don't know, X, okay? This is X if length B0 is X. What's the time complexity? O R times X times. You see? 3 loops. Yeah? In a loop. In order to finish R loop, each R loop takes X loops. Each X loop takes C loops. Yeah? So the time complexity is O R times X times C. What's the space complexity? What? What? Come on. N. What's the dimension of N?
R times X times C.
What's the X dimension? Come on. What's the dimension of X? Number of rows. This is R times c, and then this is b is maybe y times c times x. C times x, right? C times x. What's the dimension of M? Come on, R times C and times this metric A is R times C. Metric
times x.
R times X. Yes, well done. Good job. Yeah. So the space complexity.
R times x.
R times X. Well done. Got it?
No.
Okay, that's it for today. I think you got it. Tomorrow we keep talking about the metric. We talk about a little preview for tomorrow. Tomorrow we'll talk about the metric. The multiply. If you want to multiply the power, power metric. The inverse, we mentioned about the division, A divided by B. Okay. You just A divided B actually equals what? A times B minus 1, right? Look, mathematics. 2 divided by 4 equals what? 2 times 4 minus 1, right?
0.5.
Yeah?
7.
Yeah? Okay. So is it? Yeah, maybe, yeah. So what's this minus 1?
Oh no.
So it's 4 times 1 divided by 1. Okay, so it's mathematics, yeah. So this inverse, this is called inverse. So what's inverse? So something, if A times A minus 1, can you imagine equals what? This is called inverse. So A, also, we mentioned about something here. Remember, we talked about this. A minus 1 is the inverse of A if they times to what? Come on, to something, you draw this 4 times 4, what does it call?
Identical thing.
Identical metric, that's it. Okay? Yeah? Yeah, okay. Yeah, don't worry too much about details. We'll visit that later, okay? Good job today. Bye-bye.
Bye.
Say bye-bye to people.
Bye.